Okay, team challenge number 10 is an amino acid sequencing problem. So, the first thing you do when you get an amino acid sequencing question is to figure out how many amino acids you're dealing with. In this question, if you count them up, the information from part 1, you'll see that there are 20 amino acids in this peptide. So, I find it easiest if you start by putting dashes on your paper that you can then fill in later. So, and I didn't make enough dashes in the first line. That's okay. Alright, I've got 20 dashes here. The first piece of information is that treatment with aminopeptidase, which we remember releases the first or N-terminal amino acid, gives us free proline. So that means that proline is the first amino acid in the peptide. This is a really fundamental thing that you got to get that piece of information first, and it makes the rest of the problem a lot easier to do. Okay. Treatment, part 3, treatment with cyanogen bromide. Cyanogen bromide cleaves after methionines, or mets. Okay? Gives a bunch of fragments. It gives 4 fragments because there's 3 methionines there. Alright. I can't make much about this, but I can find that proline. Proline's in that third peptide. And what I know is that if this chemical treatment cleaves after methionine, then the last amino acid in this little group has to be methionine. So that third peptide there is ASX met pro and an ammonia. That's important. Then I know that pro is the first. I knew that already. Met must be the third one, and therefore I can put AS something. Now, ASX could be either ASP or ASN. When it has ammonia with it, it's ASN. This has ammonia with it, NH4. So I'm going to call this ASN. I know that now. Great. That's about all I can do, except to say the first peptide in that part has 1, 2, 3, 4, 5 amino acids in it, and it doesn't have methionine. So it must have come after the last methionine. So these 5 must go here, and there must be a methionine before them. I could go one step further and say, okay, well, the other peptides, I'm not sure of the order, so I'm just going to leave them out for now. That's all I know at this point. The fourth treatment is with trypsin. Trypsin cuts after lysine or arginine, okay? So, the way I would approach this is to look for my proline again. The second peptide has 1, 2, 3, 4, 5 amino acids, including that pro-ASN met, but it also has arginine and isoleucine. I know that it must end with arginine because that's what the cut comes after. Therefore, the isoleucine must be the one in the middle. We're working right along here. Sometimes I'll go in and look for things that I recognize. I don't recognize anything else too interesting there, so I'm going to go on and come back later. Treatment of the peptide with chymotrypsin, now that cuts after phe, tyre, and trip, gives a series of amino acids. I'm going to look for that proline again, and there it is in the second peptide. It's got 1, 2, 3, 4, 5, 6, 7 amino acids. It must end in the phenylalanine that's there. And the only other amino acid that I see there is a GLX, and the GLX brings another ammonia into it. So just like with ASX, GLX is GLU or GLN. When it's with ammonia, it gives us GLN, and we've added another ammonia in here, so we can say that glutamine is right there. So far, I guess I haven't got anything else. I'm going to keep going. Treatment of the peptide with V8 endopeptidase, which cuts after glutamate but not glutamine, gives us a little tiny 2 amino acids. So it must have been right here at the end, which means the glutamate must have come right before it, and the other rest of the peptide is there. The final piece of information is that threonine is released with carboxypeptidase, which chews in from the C terminus. So that means that the last amino acid must be threonine. And if I go back to the previous part 5, we had a little peptide that was alanine threonine, so that will tell us this. Alright, now, this little peptide, GLX-ala-threonine, came from cleavage from a larger peptide that must have had chymotrypsin cleaving site here. And if I go back to the first part, I see a peptide that has the first one. It has the alanine, the threonine, the glutamate, and then it also has a serine and a tyrosine. I know that this must have been generated by cleavage right before that with tyrosine, therefore I can fill in the serine. Now what I do is I go back to the beginning and I start looking for more things that I understand or I can recognize. So I had this first peptide, but what about this next one? I have an ILI and an ARG and all these things. I look in the section 3, cyanogen bromide, and I find this isoleucine and this arginine and whatnot. That comes in the second peptide there. So that's like 1, 2, 3, 4, 5, 6 amino acids long. It must have ended in methionine. The only other amino acid that's in that peptide is a histidine. It must go here. Excellent. Now I say, okay, what about this tryptic cleavage in part 4? It cut here at arginine, it's going to cut at some lysine somewhere else. I find that peptide with the lysine in it. It's the bottom one. It's got 1, 2, 3, 4, 5, 6 amino acids from the arginine. So this lysine must be here. It also has an ASX in it and only one ammonia. We've got a glutamine ammonia, so this must be ASP here. Okay, we're working right along. We can now go back to the first part and find the cyanogen bromide fragment. So part 3, cyanogen bromide. I'm looking for this lysine. I find that in the fourth peptide there. It's 1, 2, 3, 4, 5, 6 amino acids long. 1, 2, 3, 4, 5, 6. That's where my methionine goes. And so I've got my ASP and my lysine, and I can't say anything more at this time about that, so I'm going to have to try and go to chymotrypsin, and I'm going to again look for this lysine and see what it tells me. Chymotrypsin would have cut here, and I'm looking for something that has this his-met lyse business in it from chymotrypsin. I find that in the third peptide. It's got 1, 2, 3, 4, 5, 6 amino acids. 1, 2, 3, 4, 5, 6. The last one has to be the tryptophan, which is where this one cuts. And the other amino acid that we haven't seen yet in there is, we got the his, wait a second, hold on, I'm getting the wrong one. I've got there's a leucine that we haven't seen yet, must be there. Now, the only one left here is going to be in this little chymotrypsin fragment here that has the tyrosine in it. And that one, I'm looking at glycine met sear tyre. The only one I haven't found is glycine. So that's how you walk through it. You go back and forth through the bits of the puzzle, and then at the end, what I would do now is go through and check my cuts and make sure that everything works. And that's how you solve this kind of problem.